Hi class, welcome to a new chapter and welcome to another lesson. We're studying 5.1 Monomials and Scientific Notation. I believe this is a review lesson for us, so hopefully we should all be very good at this, but let's review it to make sure that we all have a good handle on what's happening. So when we have these two monomials that are multiplied by each other, the numbers we multiply, but the variables with their exponents, we add their exponents. So when we multiply variables together, we add their exponents. So the 3 times negative 4 is a negative 12, and then we're going to add the exponents. So x cubed and x squared makes x to the 5th. And then y squared and y to the 4th make y to the 6th. So when we multiply those two monomials together, monomial meaning one term, so here's one term and here's one term. When we multiply those two monomials together, we get a negative 12, x to the 5th, y to the 6th. This is our answer. Next one, when we have variables that are raised to an exponent, and then these exponents are raised to an exponent, this is called the power property. So when we have a power raised to a power, we multiply the exponents. So the coefficient, the number in front, we just always follow those rules. So it's going to be a negative 2 raised to the 5th power. So negative 2 times negative 2 times negative 2 times negative 2 times negative 2. And negative 2 multiplied by each other 5 times is a negative 32. And then we're actually going to multiply the exponents. So 3 times 5 is p to the 15th. 2 times 5 is p to the 10th. And there's our answer there. So when we multiply variables together, we add their exponents. When we have a power raised to a power, we multiply those exponents. So those two rules we got to make sure we have a good grasp on. Another practice problem. So here we have 3 squared, which is 9, and x to the negative 3rd squared is x to the negative 6th. So 9x to the negative 6th would be our answer, except you cannot have negative exponents. It's a math rule, you can never have negative exponents. So if we can't have negative exponents, class, the way that we get rid of the negative exponents is if they're in the numerator, you bring them to the denominator, and that makes the exponent positive. Or if it's in the denominator, you move it to the numerator, and that makes the exponent positive. So wherever it is, if it's upstairs, bring it downstairs. If it's downstairs, bring it upstairs. So right now, this is kind of like 9x to the negative 6th over 1. So to make our x to the negative 6th, x to the positive 6th, just bring it downstairs. So your 9 is still in the numerator, but x is now to the positive 6th. That is in the denominator. So this is our answer for problem number 3. 9 over x to the 6th. Let's practice some more like that. Number 4, we have x to the negative 3rd times x to the negative 4th. With common bases, we're going to add their exponents to get x to the negative 7th. So x to the negative 7th would be our answer, except we cannot have negative exponents. So once again, this is understood that it's over 1. So now we're going to bring x to the negative 7th to the denominator. So now we have x to the positive 7th in the denominator. We don't have anything in the numerator, so it's an understood 1. So 1 over x to the positive 7th is our answer for problem number 4. Number 5, 5 times negative 2 is negative 10. We're multiplying these two monomials together, and we get x to the negative 6th. So we can't have negative exponents, so bring the x to the negative 6 to the denominator. Negative 10 over x to the positive 6th. That is our answer for problem number 5. Number 6, we have a whole nother rule here. When you have x to the 5th over x cubed, so when you are multiplying two monomials, you add their exponents when they're common bases. When you have a power raised to a power, you multiply those two exponents. Now, when you have a division problem or a quotient, a fraction, with a common base, you subtract their exponents. So it's going to be 5 minus 3. So we have x raised to the 2nd is our answer for problem number 6. And we take 5 minus 3, we get 2, so x squared is our answer. Another way that we could look at this is if we have x to the 5th, we can now multiply it by x to the negative 3rd. We can bring this to the numerator, change the sign on the exponent, and now we're multiplying. So when we have common bases that we're multiplying, we add these exponents. So when you take 5 plus a negative 3, once again, you get x squared. A lot of people like to do it that way as well, which is just fine with me. No matter what, you get x squared. Let's practice some more of these quotient problems. So now we have 2 subtract 7, and we get a negative 5. So when you have common bases, you subtract, we get x to the negative 5th. However, we cannot do this. We can't have negative exponents, so that's the exact same thing as 1 over x to the positive 5th. Bring that x to the 5th to the denominator, and there's our answer. Another way that you might want to look at this is there's 2 x's in the numerator. X times x is x squared. And there's 7 x's in the denominator. 1, 2, 3, 4, 5, 6, 7. Well, anything divided by itself is 1. So this cancels and this cancels. So now all we have left in the numerator is 1, and we have x to the 5th in the denominator. Hence the 1 over x to the 5th. That's another way that you could think about this. Problem number 8. We have a quotient, so we're going to subtract these. A negative 3 subtract a negative 4. That changes to plus, so we have 1. Our exponent is raised to the first. So it's x raised to the first power. And there's our answer for problem number 8. A lot of students will want to make both of these exponents positive. So if you bring x to the 4th to the numerator, or if you bring x to the negative 4th to the numerator, it's x to the positive 4th. And if you bring x to the negative 3rd to the denominator, you get x to the positive 3rd. Now when you subtract these, you have x to the 4th in the numerator, x to the 3rd in the denominator. It just cancels and makes x to the 1st. So that's another way that you could look at this one. Problem number 9. There's a lot of ways you could do these. If I look at this one, I might bring this to the denominator, and now there's 1 over x cubed times x squared. So then you would get the number 1 over x to the 5th, because you would add those exponents. And so you'd get 1 over x to the 5th. Another way you could do it is it's a quotient, so you could just subtract. So a negative 2 minus 3, you would get a negative 5. So it's x raised to the negative 5th. But you can never have negative exponents, so that's the same thing as saying 1 over x to the positive 5th. Once again, you get the same answer no matter how you do it. Number 10. When I have a quotient here, I'm going to subtract these. So 4 minus a minus 2 is 6. So a negative 6 right here. X raised to 4 minus a minus 2 is a positive 6. So negative 6, x raised to the 6th. There's our answer for problem number 10. Problem number 11, we kind of have a twofold question here. We have a quotient inside these parentheses, and then that's also raised to the power. So we kind of have the quotient property and the power property happening at the same time. I would probably clean up these parentheses here first. I would simplify it. So a negative 2 divided by 4 is the same thing as a negative 1/2. 2/4 is 1/2. If I see x squared divided by x to the 5th, that's the same thing as x cubed in the denominator. The 2 x's cancel in the numerator, and there's 5 in the denominator, and 2 of them cancel with the numerator, so there's 3 left over. And then we have y to the 4th and y, which make y cubed in the numerator. So now that we've simplified it, now let's do the power, so we're going to square it. So looking at this, we have a negative 1 squared now turns to a positive 1. Y cubed squared, when you have a power raised to a power, you multiply, and you would get y to the 6th. 2 squared is 4, and then x cubed squared, you'd multiply again to get x to the 6th. So there's our answer for that one. We got 1y to the 6th, or just y to the 6th, over 4x to the 6th. There's our answer for problem number 11. Okay, problem number 12, we're getting into a whole new topic. It's scientific notation. So this right here is called standard notation. This is the number 6,380,000. To clean this up a little bit, a lot of mathematicians and scientists like to use scientific notation. So with this scientific notation, what it is there is one non-zero digit to the left of the decimal point. We want to have one non-zero digit to the left of the decimal point. Here is our understood decimal point, right here. And there are 1, 2, 3, 4, 5, 6, 7. There's 7 digits to the left of the decimal point, and I just want 1. So I'm going to move the decimal point 1, 2, 3, 4, 5, 6. Here's where I want my decimal point. So it's the same thing as 6.38, and I moved it over 6 times. So I'm going to say times 10 raised to the 6th power. Because I moved it 6 times, I'm moving it left, so I'm making this 6 million number very, very small. It's 6.3. So I have to make up for that by multiplying by 10 to the positive 6th. So there we have this one in scientific notation. If you move the decimal point left, you have to have a positive exponent when you multiply by 10. 6.38 times 10 to the 6th. Let's try number 2. This one is a very, very small number, 0.000047. I have several digits, or I don't have any non-zero digits to the left of my decimal point, so I have to move my decimal right. 1, 2, 3, 4, 5. I need to have one non-zero digit to the left of my decimal point, and there it is, 4. So this is the same thing as 4.7 multiplied by 10 raised to the, I moved it 5 spots, and if I move it to the right, it's going to be a negative. So 4.7 times 10 to the negative 5th. Right here, class, it's a very small number, and 4.7 I made larger than this number. So if I'm making a bigger number here, I have to make up for it by having a negative exponent here. A negative exponent means it's going to be a smaller number. So when it's a large number, like this one is, and if I make it smaller, like 6.38, I make up for that by raising it to a positive exponent. If it is a very, very small number like this one is, and I make it bigger, such as 4.7, I have to make up for that using my exponent and giving it a negative exponent. Okay? I hope that makes sense. Problem number 3. So now I have 2 numbers in scientific notation, and I have to answer it in scientific notation. So this is very similar, where I'm going to multiply the coefficients. 4 times 2 is 8. And now I have base 10 and base 10. So if I have common bases, I'm going to use the product property, which says that if I have common bases, I'm going to add their exponents. So multiplied by 10 raised to the 5 plus 7, which is 12. 8 times 10 to the 12th. The understood decimal point is right here, and there is one non-zero digit to the left of my decimal point, so I'm done with number 3. There's my answer. Problem number 4, notice this one very carefully. We're going to multiply 2.8 times 3.9. When I multiply those two, I get 10.92. 10.92. I have common bases, so I'm going to add their exponents. So times 10 raised to the 4th power. I have so many people that answer this question like this. They circle it, they move on to the next one. And it's not correct because it's not in scientific notation. Scientific notation has one non-zero digit to the left of the decimal point. I see 2 digits to the left of my decimal point. So I have to move this decimal over 1 spot. So if I move it 1 to the left, it's 1.092 times 10 raised to the, if I move this 1 more digit to the left, I'm making it a smaller number. I have to make up for that by adding 1 more over here. So instead of 10 raised to the 4th, it's now 10 raised to the 5th. 1.092 times 10 raised to the 5th power. If I move it left, I have to add to my exponents. If I move the decimal to the right, I have to subtract from my exponent. Okay, last one for the day. So now we're dividing, so we're going to use the quotient property. 6 divided by 3 is 2. There's my coefficient. 6 divided by 3 is 2. And 10 to the negative third and 10 to the first, a negative 3 minus 1. I'm going to use subtracting these exponents with the common base because that's what the quotient property states. And I would get times 10 raised to the negative fourth. And class, this is an instant in scientific notation where you can have negative exponents. You can never ever have negative exponents except for in scientific notation. So make sure you make note of that. And there's the answer for problem number 5. So tomorrow, maybe some of you have a really good grasp on this and you have no questions, and that's great. If there's something that you're missing, by all means, please ask me questions because I want to get that straightened out before we go further on into the chapter. So let me know if you have any questions when you get to class tomorrow.